Hello, I'm Tyler Bryant, and this is Drones for Tree Trimming's presentation on an optimal drone end effector for vegetation pruning. I collaborated with Matthew Ramberger, Daryl Fambro, Nikhil Patel, and Keith Leong on this project. Our goal was to design an optimal end effector configuration that integrates with the DJI Inspire drone. When we say optimal, we intend for it to perform light tree trimming and pruning of vegetation surrounding power lines, all while being able to withstand repetitive impact with grass and dirt from a height range of 30 to 50 feet. The end effector will attach to a branch and disconnect from the drone, allowing the drone to fly away while the cut is made. The motivation for this project comes from the implementation of drone use to provide safer and more reliable services to the customers of Florida Power & Light. Florida Power & Light Aerial Intelligence Response already uses drones in inspections and in hurricane disaster recovery. The mechanical assembly was accomplished by using L-shaped aluminum rods to build a frame, to which Lexan polycarbonate sheets were attached, allowing for the attachment of foam cushioning. C-shaped aluminum rods were used to mount the Ryobi gardening tool and the Actobotics parallel gripper. The Flying Tech payload release mechanism was attached to the outside of the frame to allow for attachment and detachment with the drone. The electrical system consisted of the microprocessor, battery terminals, two NPN BJT transistors, a voltage regulator, and an accelerometer for added safety features. Communications between the controller and end effector are done using UART over Bluetooth. We chose the NRF52840 chip because of its built-in Bluetooth module, which is capable of long ranges. The NRF52840DK board transmits character-based commands to the end effector's board. For example, !C initializes the cutter. The buttons on this board were mapped to these commands. The Feather Express receives the commands and parses them. It toggles the clamp, cutter, and release accordingly by sending out the appropriate signal to the appropriate pins. It also detects if the end effector is stuck after being released from the drone by using the accelerometer. If a fall is not detected within 30 seconds, the clamp releases. Here, you will see two examples of drop tests that we did to the frame to ensure it would be safe when falling from multiple distances of 20 feet and then 40 feet. As you can see in the pictures, the frame was not damaged, only muddied from the wet ground. Here, we see the entire mechanism working. The gripper grabs the branch, after which the servo releases from the drone, and finally it cuts the branch and falls. Our final result was a weight of approximately 2.5 pounds, with signal range ranging from 200 to 250 feet. The dependent variable in this range was whether or not there was a clear line of sight. Battery lifetime was approximately 45 to 60 minutes, and the fall survival height was estimated at 40 feet because that was the highest achieved safe drop. Cutting size is between 0.1 inches and 0.4 inches. Over 0.4 inches, we had inconsistencies and required multiple engagements of the cutting routine to successfully get through the branch. Future steps include, but are not limited to, additional release mechanism for vertical cuts, which would be attached to the outside of the frame. However, integrating these release mechanisms inside the frame would add them additional safety during the case of the fall. Upgrading soldered breadboard to a PCB, increased diameter and power of cut potential, adding shock absorbent mounting to all the components within the frame, upgrading the frame to titanium, and upgrading the drone to increase payload capacity. Currently, our design is based around the DJI Inspire 1, which has a payload capacity of 3 pounds. However, the DJI Inspire 2 would have a capacity of up to 10 pounds. Thank you for your time and enjoy.